Good evening, everyone. Welcome to another session of Quant, where we are going to practice questions from permutation and combinations today. And this topic is very interesting, but there are lots of concepts to learn in this topic, and there could be some tricky part when there are some condition, when there are some unique kind of scenarios, and that could always create confusion for students. So we will try to clear those confusion, and I have taken some really good questions, and we will try to cover almost every type of questions which are possible from permutation and combination, and then for every question I'll give you some time, and then we will discuss the solution. I hope all of you are ready with pen and page, right? So let's start with our first question, and before we start, let me tell you one thing, that next slide that I will put, there is a phone number given. If you have any queries regarding your CAT preparation for CAT 2025 or CAT 2025, if you have any confusion, then you can contact on that number and ask your queries. All right. These live sessions are going on every day, 5 p.m., 9:30 p.m., 11 p.m., 3 p.m. as well, and you can watch these live sessions. If you are preparing for CAT, then these will be very helpful to you guys. Okay, so let's start with our first question, which is this one. Try this one and send me your answers. How many committees can be formed comprising of one male and at least one female out of 11 males and 11 females? So there are some committees to be formed. Number of people in that committee is not certain, right? It could be minimum 2, maximum 12. So what will be the total number of committees? As I said, this is the number for our support team. Okay, and you can call on this number 81309-00243 if you have any type of queries regarding CAT preparation. Okay. So we are already getting answer. Shardul is answering C, option C. I guess yes, option C is correct. It says for how many committees can be formed comprising of one male and at least one female out of 11 males and 11 females. So what we can say, that total number of committees that can be formed. So number of male is exactly 1, that we can choose in only one way, 11C1, and we need to choose number of women. Number of women is at least 1. We can choose one woman in 11C1 ways, 2 women in 11C2 ways, and so on. We can choose all of the 11 women, right? Now what do we know? We know that NC0 plus NC1 till NCN is equal to 2 to the power n, right? And NC0 is nothing but 1. So NC1 plus NC2 till NCN will be equal to 2 to the power n minus NC0, or this is equal to 1. So from here again, what we can say about the total? We can say total will be equal to 11C1 into, this will be 2 to the power 11 minus 1, and that is equal to 11C1 is 11, 2 to the power 11 is 2048, minus 1 is 2047. Now we need to multiply these two. So 7, 4 plus 7 is 11, carry 1, 4 plus 1 is 5, then 2 plus 0 is 2, then again 2. So 22517. That is our answer, which is option C. All right. So that's the answer of this question. If you have any doubts here, then ask me. Okay, having a good control on PNC also tell you that you have a good control over algebra and numbers, right? Because some of the concepts from those topics are also used here. Now, another question. What's the answer of this question? Option C, Tanvi, Shardul. Yes, both of you are correct. In a party, every person shakes hands with every other person. If there were a total of 666 handshakes in the party, how many people were present in the party? So what we can say, if there are number of people in the party is n, then if you choose any two out of those n, then we will have a handshake. Let's say there are people A, B, C, D, E, 5 people. So if you choose any two, then there is a handshake. A and B, one handshake. A and C, one handshake. A and D, one handshake. So every unique pair that you choose will have exactly one handshake. So what we can say, let total number of person in the party is equal to n. Then according to question, NC2 is equal to 666, or NC2 is nothing but n into n minus 1 upon 2, that is equal to 666, or we can say n into n minus 1 is equal to nothing but double of this, which is 1332, right? 1332. Now n should be numbers such that n into n minus 1 should be 1332. Once again, the concept we have learned yesterday, instead of solving this quadratic, the concept that we have learned yesterday, that this value n into n minus 1 will be greater than n minus 1 square, and it will be less than n square, right? So we need to find a value of n minus 1 for which this will be 1332, right? So this is what we are looking for. So which perfect square is closest to 1332? 36 square is 1296, and 37 square is 1369. So what we can say, if I take n is equal to 36, then 36 into 37 we get as 1332. So that's why our answer n is equal to 36. Number of people in the party is 36. all right. 37, wait a second, yes, it will be 30 and n will be 37, correct. N will be 37, not 36. N will be 37. This will remain same, 37 into 36, right? 37 into 36 is equal to 1332. So n is 37, not 36. So answer is option D. Correct. N into n plus 1 by 2 नहीं होगा. N should be 37. Okay, not 36. That's why answer is option D. All right. Ayushman, your answer is correct. Shardul, Tanvi, option C is not correct. Okay, answer should be 37. 37 into 36 upon 2 is 1332. ठीक है? Is that clear? Okay. Okay. Then next question. This is a really good question. Try this one. How many numbers up to 10,000 will give the sum of digits as 9? So, what's the answer of this question? 3. How many numbers up to 10,000 will give the sum of digits as 9? So, there could be a single digit number, there could be 2-digit number, there could be 3 digits number, 4 digit. Either we can use all the 4 cases to figure it out, or we can just use one case to figure this out. Think, let's say we have 4 digit number A, B, C, D, and the sum of A plus B plus C plus D. If I take sum of A plus B plus C plus D is equal to 9, then what are the possibility that we can think of? Can we think of this number 0 plus 0 plus 0 plus 9? This will be a single digit number because 3 of them are 0. We can also think of 0, 9, 0, 0. This will be a 3-digit number where sum of the digits is 9. So 0, 0, 9, 0. This will be a 2-digit number. Similarly, we can think of number 3, 0, 3, 3, or 3, 0, 3, 3, 3, 3, 3, 0. So basically what we need to think is how many ways we can write a plus b plus c plus d as 9, right, where a, b, c, d can take the value 0 as well. If you are considering that, then it's very easy to solve. And what do we know about that formula? That x1 plus x2 till xr is equal to n, then number of ways this can be done is equal to n plus r minus 1 c r minus 1, where xi is a whole number. Xi is a whole number. So if you consider a, b, c, d, that a, b, c, d can be a whole number, what will be the number of ways here? What will be the number of ways for a plus b plus c plus d is 9. A plus b plus c plus d is equal to 9. Number of ways this can be done is equal to 9 plus 4 minus 1 c 4 minus 1, which is equal to 9 plus 4 is 13, so 12 c 3, that is equal to 12 into 11 into 10 upon 3 into 2 into 1. If you calculate, you get this value as 220, which is option A. So we don't need to calculate this using 1 digit, 2 digit, 3 digit, 4 digit number, okay. We don't need to worry about that. It will be straight away 12C3, which some of you got correct. Shardul got this correct, Siddhant got this correct, Ayushman got this correct, Kushagra got this correct. Good evening Kushagra. ओके किसी को डाउट है इसमें तो बताएंगे, अगर कुछ भी डाउट है कि सर कैसे यहाँ पे हमने सारे ही काउंट कर लिए, अगर हम 4 डिजिट ले रहे हैं तो सिर्फ 4 डिजिट नंबर क्यों कंसीडर हो रहे हैं, 3 डिजिट, 2 डिजिट, 1 डिजिट कहाँ कंसीडर हो रहे हैं ना. सो आई हैव गिवन दैट एग्जांपल दैट this one case is also working for this as well as working for this, and 9000 will also be under this. So a plus b plus c plus d is equal to 9 will have 4 different cases. So this will be counted as single digit number, this will be counted as 3 digit number, this will be counted as 2 digit number. So we are getting all the possibilities here, where sum of these 4 digits should be equal to 9, right. Whatever is 0 at initial places will be taken out. Now another amazing question which will test your concept in this topic clearly. What do? Do you take multiple cases or can you solve it in one go? $120, that's it, only 120. No, only 120 is not correct. Guys, you are putting two A's at extremes. What about when we have situation A and A, I, Q, T, like this, right? And what else? U. Are you considering these cases where N is exactly between A and between two A's? No, right? There could be multiple letters between two A's. It does not say that all the letters are between two A's. It says N should be between two A's. All the letters could be anywhere. Those could be before one of the A's, after one of the A's, in between with N, right? So, how do we solve this? See, one way to solve this question is considering different type of cases. We have 1, 2, 3, 4, 5, 6, 7 positions, right? We have 7 positions. If you consider case 1, where 1, 2, 3, 4, 5, 6, 7, we put A here and we put A here. Then N could be any of these 5 positions, right? These places can be filled in 5 into 4 into 3 into 2 into 1, which is equal to 120 ways. Now, second case, where 1, 2, 3, 4, 5, 6, we have 2 A's like this, and there are 4 places. Now, one position could be here or here. So, we will have 2 different cases, right? When there are only 4 places between A and N is between in one of them. So, there should be 2 such cases. The position of A will be 1, 6 or 2, 7. Is that clear to everyone? The position of 2 A's could be 1, 6 or 2, 7. Let me write it here. 1, 2, 3, 4, 5, 6, 7th position. 2 A's could be at position 1, 6 or 2, 7. So, there will be 2 ways. So, 2 times into, now it will be 4 factorial, which is 4 factorial into 2. What will be the value? Okay, and in that case, we can put N any of these 4 positions, right? Any of these 4 positions, and then rest of the 4 letters can be arranged in 4 factorial ways, right? Rest of the 4 letters can be arranged in 4 factorial ways. This will be equal to 24 into 8, which is equal to 192. Then comes the third case, where we have A, 1, 2, 3, A, right? In that case, the position of A could be 1, 4 or 1, 2, 5 or 3, 6, right? Anything else? 4, 7 as well, right? 1, 6, 2, 7. Wait a second. This will be 3, 3, 6. 1, 6, 2, 7. This is 1, 7. It will be 1, 4. Okay, this will be 1, 5 because in between there are 3 letters. In between there are 3 letters. So, position of 2 A's could be 1, 5, 2, 6 or 3, 7. In that case, total number of ways we can put 2 A's is 3. N can be put in any of the 3 ways, and then rest of the 4 letters can be put in 4 factorial ways, which will be equal to 24 into 9, that is equal to 216. Then we take the fourth case, where A, 1, 2, A. So again, how many cases will be there? There will be 4 such cases. 1, 1, 4, 2, 5, 3, 6, 4, 7. 4 times N can be placed in any of these 2 positions. So 2, and then rest of them can be put in 4 factorial ways. So it will be equal to 8 into 24, which is equal to 8 into 24 is this is same as this one, right? Which is 192. And then we will have the fifth case where A dash A. There will be 5 such cases, and can be put in any one of these, only one of these places, and then rest of them can be put in 4 factorial ways, right? And in that case, 4 factorial, this will be 120. So if you find the total here, if you find the total, what will be total? That will be equal to 120 plus 192 plus 216 plus 192 plus 120. So 24 into 5 plus 5 plus 8 plus 8, 16, 21 and 9, 35, 35. This will be equal to 840. 840, but the answer will be 840 minus 1 because it says rearrangement. It says rearrangement. So 840 minus 1, answer will be 839. But this was a very hectic work, right? This was a very hectic work. Can we solve this in any other way? Can we rearrange in a way such that n never appears between A? I suppose that will also take the same time. Now, can you tell me this method is clear or not? Then I will be telling you the better method, that one-liner method, which will amaze you guys, that even if that is possible. Okay, tell me, is that clear to everyone? Every single case. Siddhant, Shardul, Ayushman, Dhruv, Tejeshwar, is this method clear? Dhruv, see, Dhruv was close. His answer was 840, but see, this case, iQuanta, already in that one of the 840 cases, right? We are talking about rearrangement, if all possible rearrangement. Now, if in this word n was not between 2 A's, then our answer would have been 840. But we are talking about rearrangement, so answer will be 839. Okay. Now, let's talk about the second case. Think about this. We have A, we have another A, and should be between this. Now, there will be some cases where there are some letters between A and N, and there are some letters between N and A. So, can I say there could be ultimately this kind of situation where I can put some letters here, some letters here, some letters here, and some letters here, right? We have 4 letters. We have 4 letters, I, Q, U, and T. I need to put these 4 letters in any of these 4 positions, right? So can I say that out of these 4 positions, I can put any of these 4? I can put 1 letter here, 1 letter here, 1 letter here, 1 letter here. Arrangement will be 4 factorial. I can put 0 letter here. If I put X letter here, if I am putting X numbers of letters here, X letters here, Y letters here, Z letters here, and W letters here, can I say all of these can be 0? All the 4 letters can be at W. All the 4 letters can be here, or here, or here, or here, or all the 4 letters could be in these 4 places as well. So all the cases will be covered here. Can I say X plus Y plus Z plus W should be equal to 4, right? X plus, so this number of ways, what will be number of ways or total number of words? So this will be 4 plus 4 minus 1, C4 minus 1 into 4 factorial. Why 4 factorial? Because these 4 letters can arrange themselves in 4 factorial ways always. Okay, whatever cases we are taking. So this will be equal to 7C3 into 24. 7C3 is 35 into 24, which is equal to 840 minus 1. We forgot the minus 1 here, so put the minus 1 here. This will be equal to 839. Now you can see this can be done in one step, right? This can be done in only one step. I hope this is clear to everyone, right? X, Y, Z, and W are number of letters out of these 4 letters that are being put at this position. In that case, every case will be considered. Okay? Chalo, it was a good question. Let's move on to the next one. This one. Try this one. Yes, Ayushman, it was a great application of number of ways of finding sum of whole numbers. (42 मेल से है? 42 मेल्स कैसे होंगे? How did you get 42 males? In a musical reality show, each participant had to sing a duet with every other participant. 21 duets were sung by 2 males. So, if number of males is equal to m, then if you choose any two of these m males, there will be a duet, right? So what we can say, MC2 is equal to 21, है ना? और m into m minus 1 upon 2 is equal to 21, और m into m minus 2 is equal to m into m minus 1 is equal to 42, that is equal to 7 into 6. We can say m is equal to 7. ठीक है? And number of females, if number of females is equal to f, okay, 28 duets were sung by 2 females. So out of these 8, if out of these F females, if you select any two, you get one duet females, one duet with females. So what we can say, FC2 is equal to 28, or F into F minus 1 by 2 is equal to 28, or F into F minus 1 is equal to 56, which is equal to 8 into 7, or we can say F is equal to 8. So if F is equal to 8, M is equal to 7, it says how many duets were sung between a male and a female. So number of duets required, number of duets male and female is equal to, so number of males is equal to 7, number of females is equal to 8. Every male can have 8 duets with females. So 7 into 8, this will be equal to 56. Okay, this will be equal to 56, which is option C. है ना? m into m plus 1 नहीं करेंगे ना यहाँ पे, it will be m into m minus 1 by 2 as well, है ना? Because in case of males, you can choose any two males, there will be a duet. Now, but in this case, it will be one male, one female. So number of males can be selected in 7 ways, number of females can be selected in 8 ways. So 7 into 8 is 56. All right. चलो बढ़िया. Let's try the next one. All right, looks like a tricky question. So let's try this one. Says how many 6-digit numbers can be formed from the digits 1, 3, 7, 9 such that each digit is used at least once. If each digit is used at least once, what we can say? If you want to make a 6-digit number, you can take one digit thrice and rest of the 3-digit once, right? Say in that case, what will be the number of ways? So we will figure that out. Then again, we can take 2 digits twice and then 1 plus 2 digits once. So what will be the total number of ways? In the first case, out of 4 digits, which one we are taking thrice? So 4C1. Out of these 4 digits, we can take any of the digit thrice, right? Any of the digit thrice. And then number of ways of arranging them after 6 digits, 3 of them are same. So 6 factorial by 3 factorial, that will give us 4 into, this is equal to 120, that is equal to 480, right? And then, wait a second, let's do the calculation together and take the cases once. Now out of 4 digits, we need to take 2 digits twice. So it will be 4C2. And how many numbers will be there? How many such numbers will be there? 6-digit numbers where 2 digits are repeated twice. So it will be 6 factorial divided by 2 factorial into 2 factorial. So this will be equal to 4 into 6 factorial, 720 by 6. This is 120 plus 4C2 is 6 into, this is 720 by 4, which is equal to 180. This will be equal to 480 plus 1080. That will be equal to 1560. So this is your answer, 1560. Option C is your answer. है ना? If you want to make 6 digit, using every digit at least once, either you will have to use 1 digit thrice or you will have to use 2 digits twice, right? Something like, see, for example, something like 1, 1, 1, 3, 7, 9. How many digits will be, how many such numbers will be there? 6 factorial divided by 3 factorial. Then you can take 1, 1, 3, 3, 7, 9. How many such numbers will be there? So it will be 6 factorial divided by 2 factorial into 2 factorial. Now instead of 1, it could be any of these 4 digits. So 4C1. Instead of 1 and 3, it could be any 2 of these 4. 1, 3, 1, 7, 1, 9, then 3, 7, 3, 9 or 7, 9. So that's why 4C2. So 4C2 is 6. Okay. I hope this is clear now. All right. Okay, then let's move on to the next question, which is this one. So this should be very easy question, right? In how many ways can you select none or some or all rings from a bag containing 9 different colored rings? Means out of 9, you can select 0, or you can select 1, or you can select 2, or you can select all of them, 9C9. And we just discussed in first question today that this is equal to 2 to the power 9, and that is equal to 512, right? Which lots of you got this correct. Tejeshwar got this correct. Shardul got this correct. Very good. Okay, let's go to the next question now. Okay, so in this question, it says in how many ways at most 19 chocolates are distributed between 4 children such that each child gets at least 2 chocolates. है ना? It says in how many ways, it should be, I don't think it should be at most, it should be 19 only, okay. In how many ways 19 chocolates be distributed, okay. In how many ways 19 chocolates are distributed between 4 children such that each child gets at least 2 chocolates. This is the question. Now, can you solve it now? It's not about at most 19, okay. I guess there was some problem framing this question. Otherwise, we will have to consider lots of other values like 19, 18, 17, any value which is greater than 8. Yes, then it will be answer will be option B. In how many ways 19 chocolates are distributed between 4 children such that each child gets at least 2 chocolates? So, if we give 2 chocolates to each of these 4, then we are left with 11 chocolates. And first one is getting A chocolate, second one is getting B, third one is getting C and D. Then A plus B plus C plus D should be 11, and we are looking for whole number solution, right? So, it will be equal to total how many ways? It will be 11 plus 4 minus 1 C 4 minus 1, and that will be equal to, it will be 11 plus 4 15, so 14 C3, that will be equal to 14 into 13 into 12 upon 3 into 2 into 1, so 6 into 2. 14 into 13 is 182 into 2. It will be 364. Okay. Option B is the correct answer, which lots of you got. Shardul got it correct. Tejeshwar got this correct. Hai na? Okay. Let's go to the next question. In the last question, if question was same like at most 19, then what we need to do, that A plus B plus C plus D should be less than equal to 11, right? And there you can add one variable E, that A plus B plus C plus D plus E is equal to 11, and then you can solve it. Then it will be 15C4 will be the answer. Okay, 15C4. Then we will consider all the cases there. But as per the options, as I said, it was not at most 19, it was 19. So that's why the answer was 14C3. Otherwise, answer will be 15C4. That is A plus B plus C plus D plus E is equal to 11. Shardul, 15 means, see, if it was at most here, okay, if it was at most here, can I say that A plus B plus C plus D should be equal to 11, right? Then we can introduce one variable, A plus B plus C plus D plus E should be equal to 11. Now, if E is 0, this is 11. If E is 1, this will be 10. If E is 2, then this will be 9. So every cases will be taken here in case of at most. So for this, number of solution will be 11 plus 5 minus 1. So 15C4. ठीक है, समझ गए? Okay, 15 is polygon. Okay, this one. 15 is the number of sides in the polygon, correct? But not the answer of this question. Not the answer of this question. Okay. It says the number of diagonals in a convex polygon is 90. What do we know about number of diagonals? Number of diagonals is equal to n into n minus 3 by 2, right? N into n minus 3 by 2 if number of sides is n, and this is equal to 90. Then n into n minus 3 will be equal to 180. It's very easy to write 180 as a product of two numbers, two positive integers which difference of 3. So it will be 15 into 12. Again, I am telling you this so that you don't have to solve quadratic again and again in these kind of scenarios. Okay, whenever you know these numbers are natural number or positive integers, you can quickly find out the answer here. You can save some time by not solving the quadratic to get the answer. So n is equal to 15. Now think about this. It says find the maximum number of intersection points of diagonal. Whenever we are talking about intersection points of diagonal, think about this. Whenever we have two diagonals, what are we doing here? We are taking four vertices, right? We are taking four vertices. If you are taking any four vertices, you are getting two diagonals, right? Can I say this? Batao, yes or no? Out of 15 vertices, if you are choosing any two vertices, you will get two diagonals. Sorry, you get two diagonals. And out of those two diagonals, we need to select. Whenever you have two diagonals, there will be exactly one intersection point. Out of any two diagonals, there will be exactly one intersection points, right? If we are talking about maximum number of intersection points, then we will have to assume that polygon is like this, such that every two diagonals are intersecting at distinct points. So in that case, what we can say, we need to choose 4 points out of 15 points. We need to choose 4 points. So total number of intersection, it will be 15C4. That is equal to 15 into 14 into 13 into 12 divided by 4 into 3 into 2 into 1. So 4 into 3 is 12, cancelled out. 2, this is 7 times. This will be equal to, what's this value? 15 into 13 is 14 square minus 1, 195 into 7, 200 into 7, 1400 minus 35, 1365. This is the answer, है ना? That's the answer of this question. So Tejeshwar, that is correct. Simran, that is also correct. Good. Now let's try the next question. This is another question which is based on selection of things. This is a 6 into 8 grids. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. This is a 6 into 8 grid. Now, what kind of rectangles we can choose from this? We can choose rectangle of side 1 into 1, 1 into 2, 1 into 3, 1 into 4, 1 into 5 till 1 into 8. Then we can choose rectangles of size 2 into 2, 2 into 3, 2 into 4 till 2 into 8. Then we can choose rectangles of size 3 into 3 into 3, 3 into 4 and so on till 8 into 8. So how do we calculate all of these rectangles, right? So it's very simple. Once you understand it, it's very difficult to forget it. See how many vertical lines are there? 1, 2, 3, 4, 5, 6, 7. How many horizontal lines are there? 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now out of these 7 vertical lines, if I choose any 2 vertical lines, if I choose any 2 vertical lines, let's say these 2 vertical lines, I have chosen, okay? A vertical line number 3, vertical line number 5. Then if you choose any 2 horizontal line, any 2, let's say line number 2 and let's say line number 7. So we get a rectangle, this rectangle. We are getting one unique rectangle, right? Can I say this will happen as many times I can do this, like out of 7 vertical lines, how many ways I can choose any 2 vertical lines? So number of rectangles is equal to, out of these 7 vertical lines, I can choose any 2 vertical lines in 7C2 ways. And out of these 9 horizontal lines, I can choose any 2 horizontal lines, and in each case I will get one unique rectangle. So 7C2 is 7 into 6 by 2, which is 21. 9C2 is 9 into 8 by 2, which is 36, which gives us 756. And that's your answer. This is an amazing concept, right? If you understand it well, this is a very easy question for you. Otherwise, there is lots of confusion regarding how to calculate it. So Tejeshwar got this correct, Ayushman got this correct. So very nice, both of you. You two are really practicing it out of the park, right? So I'm really happy for you guys that you are able to solve these questions with ease. Okay. Now, if you are preparing for CAT 2025, you can choose iQuanta iCat mocks, which provides you 35 CAT level mocks and 45 sectionals. And all of these will have video solutions and AI mock analysis. iQuanta iCat was the first mock with AI analysis, and still we have improved lots than last 2 years, and today we have improved such that you don't have to make any kind of Excel sheet on your own to keep the record of your progress after each mock. You can just follow the AI analysis, and you will know what's your weak point, what's your strong point, everything. So if you are looking for mock test, it's really important that you have iCat mocks. Apart from that, we have IMABC practice batch, which is for the students who are targeting very high percentile. Okay, so in this batch you get 7,500 questions which are faculty curated for students who wants to score really good percentile in each of these sections. Okay. Ayushman is saying there are silly mistakes. I am working on it, and with your help recollecting old ideas as well. Ayushman, you are going good, so don't worry about it much. Just keep practicing in the way you are doing, okay, and you are good. Okay guys, and our last batch, okay, only 5 months are left, even less than 5 months are left. So this is your last chance that you can ensure that you are getting 99 plus percentile with the hard work that it needs, and for that you need iQuanta, which provides you 10,000 plus question in dashboard along with crash course and mocks. You are getting your syllabus covered thrice by CAT exam. So what's better than that? So our last batch is starting very soon, and lots of new features are there, like LRDS Inception, Quant for non-engineers, then VRC for engineers. Lots of things are there which will help you starting below the basics. Not only the basics, below the basics. If you are not good in quants, those videos are very helpful. If you are not good with VRC, there are videos, there are pre-class videos, and same for LRDI Inception. Okay, so if you are looking to crack CAT 2025 with really good percentile, then this is your place. Last year, 99 percentilers are 500 plus. In iQuanta, 500 plus students got 99 plus percentile. And the most amazing part, that the maximum number of those students were from last batch only, because this is a do or die situation. So once you get in, there is no coming out. You will have to work every day and you will have to work hard. Okay. So if you have any queries, any question, you can call us at the given number here. This is the number 8130900243. Okay, and we will try to resolve your queries as much in detail as possible. Okay, so that's it for today, everyone. Thank you very much for joining. Bye bye.